Okay, in the last video we saw an example of scaling in Python. In particular, we saw how in OpenCV the images can be scaled using resize function. And I also told you that we will actually explore how that is happening under the hood. So here in this video, I'm going to talk about the underlying theory of scaling, how scaling actually happens. In this particular video, and maybe in the next video, we will talk about scaling in continuous space, and we will see the theory that we have learned in the continuous space, how that can help us to go to the images. Although the images has discrete cells, that can bring its own challenges, but nevertheless, all the theory that we will learn here in the continuous paradigm will help us to go to generalize it to images, or at least use it to images with certain modifications. So let's start. Let me first write the equation for scaling in the coordinates. Remember, all these geometric transformations, including scaling and other geometric transformations, they are transformations on the spatial coordinates. So remember, a pixel in the image, for example, in an image, a pixel basically is defined as, if that's a grayscale image, it is defined as three things. Number one, it's x position. So maybe the x position is 20, which is the row number. It's y position, which is basically the x position is the column number and y position is the row number. So x and y, let's say maybe that is 40. So x is, if x is this particular distance, if that is 20, and y is this particular distance, and if that is 40, then these two things are called the coordinates of the pixel, and then whatever the intensity is inside. So for example, 200 in the case of grayscale image. In the case of RGB image, there will be three numbers, one for red, one for green, and one for blue. So a pixel, basically every pixel in an image has a position associated with it, its XY coordinates in the grid, as well as an intensity. An intensity might be one number in case of grayscale image, and intensity might be a tuple of three numbers in case of colored images. And these geometric transformations, scaling and other transformations, they actually transform the coordinates, the spatial coordinates. They actually do not hurt the intensity. So the goal is to transform the coordinates and get the new coordinates, and then try to copy the intensity at the destination. So let me explain that in bit by bit pieces to understand. So consider, for example, that's XY space. Just consider that is X and this is Y, and that is some coordinate. Let's say that is some point, let's say 0, 0, and let's say this height, this width is, let's say 2, and this height here is, let's say 1. So this is 2, this particular point is 2, 0, and this particular point is 2, 1. This particular point is 0, 1. Similarly, this particular point is minus 2, 1. Similarly, this particular point is 0, minus 1. No, it is minus 2 and 0, and this point, and then we have coordinates of this point, then we have coordinates of this point. Now, what if we want to double this square? This is not a square, this, yeah, it's a square basically. It's, no, it's not a square, it's a rectangle, because its width is 4 and its height is 2, so that's a rectangle. What if we want to double the rectangle, which means we want to double the width and we want to double the height, let's say, and we do not want to change the orientation of the rectangle. If it is axis aligned rectangle, we want it to stay axis aligned rectangle. which means we really want these coordinates 2, 1 to go to 4, 2, and we want these coordinates -2, -1 to go to -4, -2. And if you now see, the width will become 4 plus 4, which is 8, which is double the original width, and the height will become 2 plus 2, which is 4. So originally the size of the rectangle was 4, 2. That's the width and that's the height. And now we have width as 8 and height as 4. So the real question is, how can we double these? How can we double the area? And obviously this point, which originally was 2, 0, it has gone to 4, 0, and all other coordinates accordingly. So basically we want the original coordinates as, let's say the original coordinates of a point is 2, that's the x coordinate, 2. We want this to multiply, let's say, with something to give us 4, which is this. And then the original coordinates is, let's say, 1. We want this 1 to be multiplied maybe with some other number, and we want to get this 2. And whatever these two numbers, let me call these numbers as sx, and let me call this as sy. Whatever these sx and sy numbers are, the same numbers should respect to map 2, 0 to 4, 0, and -2, 1 to -4, 2, -2, and so on. So what are these two numbers that map the corresponding points? This point to that point, this point to this point, this point to that point, and all the corresponding points. What are these two numbers? What do you think? So yeah, let's see that. Let's figure that out in our next video.